In this section, we want to find the domain of definition of this function of two real variables, arc sine x plus y divided by x squared plus y squared. So first, we have arc sine of some argument. We know that arc sine looks like that, and it accepts arguments between 1 and minus 1. So the argument x plus y must be between plus and minus 1. So this is an abbreviation for two inequations. Usually, we are more comfortable with equations than inequations. So let's start with this one, and instead of less than or equal to, let's write for the moment just 1, just equal to 1. But we should write some note so that the reader is not confused in thinking that we have come to this result from this. So something like first we consider, that means this is not our result of this computation, this is our consideration. We prepare the material. But x plus y is 1, this is easy to guess, or easy to sketch. Y is 1 minus x. Okay, then let's consider the left part. Minus 1 is equal to x plus y. This is also easy to sketch. Y is minus 1 minus x. So if we plot the two graphs of these two functions, of these two curves in a single plot, we have two parallel lines like that. And now, if we consider this being less than or equal to 1, let me take a different color. If we consider less than or equal to 1, then this is less than or equal to 1, and we are below this line. And if we consider here greater than or equal to minus 1, then y is greater than or equal to, because remember we moved y to the left, so we are above this. So we want to be simultaneously above the bottom line and below the top line simultaneously. So we want to be in this band. So that would be the domain of definition if there were no fraction. But then, to divide, we want the denominator to be different from 0. Well, obviously, for any real x and any real y, this will be never negative. Usually positive, but it may be 0, namely when x is 0 and y is 0. And we don't want this situation. So the point xy must be different from 0, 0. So should we write x is different from 0 and y is different from 0? Or should we write x is different from 0 or y is different from 0? If we want to avoid vanishing x, vanishing y, then we want to remove all the points where x is 0. So instead of full line, we just sketch the dashed line. And if we want to avoid 0y, then we want to delete, we want to remove even the points on the x-axis. But this is too much. We want to delete just the origin itself. So the correct result is that x is different from 0 or y is different from 0. So we delete the origin only, nothing more. Okay, so when we have this band and we want to remove the origin, we just sketch an empty bullet in this crossing and we are done. So this is graphical representation of the domain of definition of this function. Well, and to write it down, domain of f is the set of all points x, y from R2 such that well, we can write this -1 is less than or equal to x plus y is less than or equal to y, and x is different from 0 or y is different from 0. Well, to sketch the graph of this function, this is slightly beyond the scope of Mathematics B, but if you take some software like Mathematica, Maple, MATLAB, or even some web page like Wolfram Alpha, or even Google itself, the search engine, if you give it a function of one variable, you get a curve. If you give it Google a function of two variables, you get the surface, you get the graph, and the nice picture of this. Yeah, we can discuss the properties of this set. Is it open? No, it is not, because these boundary points belong to the set and they have neighborhood which does not belong to the set. Is it closed? What's the complement? What's the complement? R2 minus domain of f. So these two lines do belong to the set, so they don't belong to the complement. What is above and below does not belong to the set, so it does belong to the complement. But as the origin does not belong to the domain, it does belong to the complement. So we must add this point. Well, and because of this point, the complement is not open, so the domain is not closed. Is it bounded? No, it is not, because it goes far away to infinity in these directions. Is it connected? Yes, it is, because any two points can be connected with a curve in the set. And is it convex? No, it is not. Because many points can be connected with a straight line, but sometimes the straight line should go through the origin, and that means that such a line is not in the set. So because of this little one point, the set is not convex. And what's the boundary of this domain? The boundary in this case consists of three parts, namely the upper line, the bottom line, and the origin itself. These boundary points are simultaneously intersect, and this boundary point is not intersect.